Assalamu alaikum wa rahmatullah. Welcome back to problem 2, still on magnetism. Okay, this one says the sun emits streams of charged particles. Okay, from the surface of the sun, the temperature there is so high that the gas that exists there are split into ions. Okay, positive and negative ions. So they say that the sun emits streams of charged particles in what is called the solar wind. Solar wind. Now, the particle, they say that the particles move towards the Earth at very high speed. A proton, which is one of the particles, of course, is moving towards the Earth, towards the equator of the Earth at a speed of 500 kilometer per second. This is the speed with which it approaches the equator of the Earth. At this point, the Earth field is 5.0 times 10 to the power of minus 5 Tesla, okay, directed parallel to the Earth's surface. Now, the questions are, A says, what are the direction and the magnitude of the force on the proton? Force is a vector, so you get the magnitude, you also get the direction of the force on that proton. Then B says, okay, we know that when the proton is approaching the Earth, it's not moving along a straight line just like that. It is moving along its circular path as it approaches the Earth. So the question is, what are the radius and the period of the orbit in which the proton moves? Since the proton, let's say this is the Earth, the Earth is here, and the proton is approaching the Earth, it is not just approaching like this as a car approaches a motor park. No, it is moving along a circular path, whirling along a circular path as it is approaching the Earth. So the question here is, if it is moving along a circular path, this cycle, what is the radius of the circle? And then it is moving along a circular path, so it must have period of oscillation, period of rotation. What is the period of that rotation along its orbit? uh, this is just an introduction to understand the question very well before you start any calculation. Okay, um let's start solving right away, and believe me, you will enjoy it. So I'm going to write solution, and I am starting with problem A. Okay, um we are going to draw, we are going to sketch the earth. Let's say this is the earth. Okay, this is our earth, for example, and then the equator is a line that divides the earth into two equal hemispheres. So this is the equator of the earth, and we know that we have magnetic field, lines of magnetic field of the earth running from south all the way to the north. Okay, so this is the direction of this is the line of magnetic field. We are taking just only one. What we are told here is that um, um, parallel to the equator, at the equator, you see, this is where the equator is. At this point, if you draw magnetic field due to the earth, okay, it will be parallel to the earth itself. So it means the magnetic field due to the earth at this point, you see, is this is the magnetic field of the earth at this point. Okay, now if the electron or proton, they say proton, if it is approaching the earth in this direction along this line, okay, and remember it is whirling as it comes, and it has its own orbit, okay, as it comes. So you have two kinds of motion here. You have translational motion, because it moves from a point to another point, and at the same time you also have circular motion. So we take the velocity with which it approaches the earth, and we assume that it is also equal to the speed, the rotational speed. So it's the direction of the velocity is here towards the earth. Can you see? Towards the earth. This is velocity vector towards the earth. Clearly, the angle between these two, the magnetic field and the velocity, is 90 degrees. Clearly, this is 90 degrees. So, how do we get the force? How we use the right hand rule? Okay, according to the right hand rule, if you want to get the force on a charged particle moving in a magnetic field, you use your middle finger, your forefinger, and your thumb. You arrange them, okay, in such a way that they make angle 90 degrees to each other. This one this way, this one, you see, the angle between my forefinger and my middle finger is 90 degrees. The angle between my thumb and my middle finger is also 90 degrees. Finally, the angle between my forefinger and my thumb is also 90 degrees. Okay, then this thumb should point in the direction of the particle's velocity, the charge velocity, and this one in the direction of the vector, the magnetic field. And then this, your middle finger will point in the direction of the force. So to do that, you see, I have to do it like this. You see, I have to make this one. Okay, you see, my thumb should be in this direction, in line with the direction of the 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 velocity. The velocity is this way, so my thumb should be here. Then the magnetic field is this way, so my forefinger pointing in the direction of the magnetic field should be like this. You see, so if I align them like this, clearly the force is downward. You see, the force is downward. When you do it properly, you will find out that the force is downward. This one is horizontal, this one this way. And see my I don't know if you can see my forefinger. You see, it's downward here, and then this one should be here. It should be touching the page, please. It means it is into page. And this one horizontal, this one to the left. So this way we can say that we have the force into page. According to the right hand rule, our force is what? Into page. Okay, the force is into page. Okay, now that the force is into page, we know the direction of the force, because here they say what are the direction. We know the direction now is into page. And the magnitude of the force on the proton. How do we get the magnitude? What formula do we use? The formula we are going to use is the one that says the force, the magnitude of the force on a charged particle moving in a magnetic field is equal to the magnitude of the charge itself multiplied by the vector, the cross product, of course, the cross product of the field and the velocity of the charged particle. See that? This is the formula. Now we move on and say, okay, we have this magnitude of the charge. This bracket is important because if the charge is negative, the bracket here will cancel the negative sign and you have a positive value of the charge. And then cross product of this vector, this and this, we have becomes magnitude of b. B without the vector head arrow here means magnitude of b. And then this one v here, okay, this means magnitude of this one. And then sine, the angle between them, is 90 degrees. But we also know that sine 90 degrees is 1. So if sine 90 degrees is 1, our formula reduces to QBV, because when we multiply everything here by 1, you get 1. So in bracket, you write it here that sine 90 degrees is 1, and this is why the formula reduces to this. Okay, we were told that the particle is a proton, so we are going to use the charge on a proton. A proton has identical charge with the electron. The only difference is that the proton's charge is positive while that of electron is negative. So you see, we are given proton's charge as 1.6 times 10 to the power of negative 19. So this should be taken 1.6 times 10 to the power of negative 19. Okay, this is our protons charge. Then the next one is B, magnetic field. Magnetic field at the equator. Okay, we are given, look at what we are given here. They say at this point the earth field is 5.0 times 10 to the power of minus 5 in Tesla. So we write it 5.0 times 10 to the power of minus 5. Okay, finally V. Okay, this V is given in kilometer per second, but kilometer per second is not the SI unit of V, so we have to convert our V. Our V is 500 kilometer per second. Then this should be 500 times the kilo here means 1000. Once you put the 1000, you remove the kilo and you now have meter per second. Then this is in index notation. This is 10 to the power 5 times 10 to the power of 5 in meters per second. So now you bring this one here, 5 times 10 to the power of 5. Okay, the rest is a calculator business. So you bring your calculator, and now press all of these. 1.6 times 1.6 exponential negative, oh that was wrong, 1.6 exponential negative 19 multiplied by 5.0 exponential negative 5 multiplied by 5 5 exponential 5. So this will give you at the end you have 4 times 10 to the power of minus 18. And remember, you are calculating force. The SI unit of force is the Newton. So your force is given in Newton. You got the force in Newton. So this is the magnitude of the force. Remember, this is the magnitude of the force and this is the direction. We mean that as it approaches the earth with this speed, 500 km per second, it experiences a force that is into page, okay, and the magnitude of the force is 4 times 10 to the power of negative 18 Newton, which is an extremely small force, of course. So with this, we have solved problem A. Let us go to B and find out what we are supposed to do. Okay, for B says what are the radius. You see, you are expected to find R, the radius, and the period of the orbit in which the proton moves. We say that the proton, as it approaches the earth here, okay, it is moving along a circular path. It has its own circular path as it is moving. Okay, it has its own circular path. It moves along a circular path. So the question is, what is the radius of this orbit? Okay, what is the radius? It is wailing like this as it approaches the earth. So we want to know, if we take one of its circle, what will be the radius? Again, what is its period? Meaning, how long does it take to cover one complete circle? Okay, to move one complete circle, to complete one rotation, how long does it take? That's period. Okay, since it is moving along a circle, we ask ourselves, where does it get the centripetal force? Because we know if a particle is moving along a circular path, it has centripetal force. So the question is, what is the source of the electropetal force? We've just calculated here that it experiences a force in the magnetic field. This force gives it the centripetal force. Okay, it is the one that becomes its centripetal force and gives it the ability to move along a circular path. And we know that centripetal force is mv square over r. That is centripetal force. and then we say this centripetal force is equal to the force it experiences. Can you see that? It equals to the force it experiences. So you can just say that, well, this is equal to what you have here, 4 times 10 raised to the power of 18, okay, in Newton, because this is actually the source, okay. And now from here you can get the radius. The radius, you simply bring this one here, so you have mv square over 4 times 10 raised to the power of 18, and then you move on and say, okay, what is the mass of the proton? You are given this value. Look at the proton's mass is 1.67 times 10 to the power of negative 27. So you put that 1.67 times 10 to the power of negative 27, and then you multiply this by v squared. What is its speed? You got the speed here. You are given this speed, 500 kilometer per second, and we converted that to 5 times 10 to the power of 5 exponential 5. So you have 5 exponential 5 for the speed, but this speed should be squared, so we are squaring the speed because it says v squared. Now everything divided by 4 exponential 18. Is it 18 or negative 18? What did we get? We got negative 18 here, and I am writing 18. This should be negative 18. So we have 4 times 10 raised to the power of negative 18. Okay, that's the radius. Then this is equal to, then you bring your calculator here and say, well, okay, now I can start with the denominator, with the numerator. So 1.67 exponential negative 27 multiplied by, then I open a bracket and say 5 exponential 5. I close the bracket and square it, then divided by what I have here, the denominator, 4 exponential negative 18. Now I can press the equality sign. It gives me in fractions, so I press SD, it becomes decimal. Correct to one decimal place, I will have 104.4 in meters. Okay, this is my radius. Clearly this is my radius. Now after obtaining the radius, problem B doesn't just say radius of the orbit, it also says the period, meaning how long does it take to make one complete rotation along its own orbit as it approaches the Earth. So we're going to say, okay, let's assume this is the orbit, okay, and here we have the center, here we have the radius here, okay. If it moves from here round here and comes back to here, the time it takes is the period, okay. How do we get this period? That's the problem. So we see that v, its speed along this, is equal to the distance covered. We know that the speed is distance over time, and the distance is the circumference. When it moved from here to here, it has completed one circumference, and we know that the circumference of a circle is 2 pi r. Can you see that? Is 2 pi r. So we are going to write 2 pi r here. This is the distance it covered. Okay, then remember the time it takes when it covers this distance is our period, and period is denoted by capital T. So we have the formula. Now we can make T the subject of the formula and say T is equal to 2 pi r divided by V. We move on and say, okay, this is equal to what is our okay, 2 pi is a constant, and then r, we got the r from the previous calculation, 104 in meters, close bracket, divided by what is our v. We are given the speed don't forget the speed. We are given the particle speed, the proton speed. We converted it 5 exponential 5. So we have 5 exponential 5 in meters per second. Clearly meters cancel meters, and the per second will emerge to become second here as our unit. So here we press 2 shift pi multiplied by 104.4. Then we divide this result by 5 exponential 5 and see what we get. This is equal to 1.31, okay, times 10 raised to the power of minus 3, and you know it's in second. Now, to be more scientific, we know that 10 raised to the power of minus 3, this 10 raised to the power of minus 3 is milli, denoted by small m. So we can say this is equal to 1.31 and then millisecond. This is our result. I hope it's clear to all of you. I wish you well as you write this examination. Assalamu alaikum wa rahmatullah.